Alright, so this is the Chemistry Section 11.3 lesson video, Part 3. My gosh, I feel like we're never going to finish this section. Alright, so first question, we're just going to knock out the section assessment. I know the other videos were long, so that way, if you felt like you got it, you don't really have to watch this one because it's just the section assessment. But first one is, what is a net ionic equation? So a net ionic equation is an equation that only shows the substances that actually react. There are no spectator ions. Okay, so a net ionic equation only shows the substances that react. It does not include the spectator ions. So number 2, how can you predict the formation of a precipitate in a double displacement reaction? Well, you use your solubility rules, which you may want to get those out just the same for the section assessment. Alright, so you use the solubility rules. So number 3, it says write the net ionic equation for the following reactions. Okay, so it's the net and not the complete. You know that even I don't really like the complete that much. Alright, so when we're writing the net, the first step is balance the reaction. Alright, so I have 1 PB, 1 PB, I have 2 acetates, but here I only have 1 acetate. So I'm going to put a 2. I have 1 H and 2 H's, so I'm going to put a 2. I have 2 Cl's and 2 Cl's. So now I balanced it. Remember, when we're writing net, we want to get rid of anything that's aqueous on both sides because it's not doing anything. Okay, so I find that I have a solid, because remember, solids, liquids, and gases are going to have to be in there. So let's start over here. So lead was aqueous, now it's a solid, so it did something. So I'm going to keep lead. Acetate was aqueous, it's still aqueous, so it did nothing. Hydrogen was aqueous, it is still aqueous, so it did nothing. And chloride ion was aqueous, and it is a solid now, so it did do something. So that means I need to save lead, I need to save chlorine, and I need to save lead 2 chloride. So I pull those down. So Pb can have multiple charges, so I'll look at acetate. On your polyatomic ion sheet, acetate has a -1 charge. However, there are 2 of them, so that's really a -2 charge. What cancels out a -2? A +2. So I'm going to bring down Pb, +2, and since it is an ion alone, it is aqueous. Alright, now you got to be careful here, because I boxed in chlorine, or the chloride ion, but you got to take into account this coefficient, because remember, it technically goes to both. So I have 2 Cl's, and Cl has a -1 charge because it's in group 17, and it is aqueous. And then it forms PbCl2, which is a solid. Okay, in this class, we are not going to address weak acids in their aqueous form, but if you move on to like AP Chem or something like that, you'll discuss a little more about that. But I did just want to point that out. Alright, so part B. You may want to pause it and try this one on your own. You really got to be able to do these on your own. Alright, I'll assume that you've already tried it and got it right, of course. So let's look at it together. So the first step is I'm going to balance the equation. So I have 2 ammonium. Ammonium's just NH4. 2 ammonium. Here I only have 1 ammonium, so I need to put a 2. I have 1 S, 1 S, 1 CO, 1 CO, 2 nitrates, and 2 nitrates. So we're good to go. Alright, so I can automatically see there's a solid right here. Everybody else is aqueous. Alright, so now let's figure out who actually did something. Well, my NH4 or my ammonium is aqueous, and it's still aqueous, so I don't care about it. My S was aqueous, but now it's solid, so we care about S. CO was aqueous, but now it's a solid, so we care about CO. Nitrate was aqueous, and it's just still aqueous, so it's a spectator. It didn't actually react. Alright, so then we just pull down what we need. So sulfur is in group 16, so it has a -2 charge, and it is aqueous. CO is a transition metal, so it can have multiple charges, so we just look at what it's bonded to. NO3 is a -1, that's on your polyatomic ion sheet, but there's 2 of them, so that's really -2. So what cancels out a -2? A +2. So cobalt is going to have a +2 charge, but it's also aqueous. And they're going to bond together to make a solid. So hopefully you got that right. Remember, if you wanted to switch those, that's okay. I really want to, but I'm trying not to force things that I just like to do on y'all. I'll try to only force, actual rules on y'all. All right, so hopefully you got one of those right. If not, you just need to do a little bit more practice. You can always go back and practice with the ones in your notes packet. Just, cover up your answers so you don't see what it is. All right, so there's my answers. All right, so let's look at this. So this is predicting the product. So this is where you'll want to use your solubility rules. All right, so we'll do the first one together, and then you should try the next one. Or really, you should try both of them, because you should have just watched that video. All right, so remember, it's double displacement because they are two compounds. They're both paired together. So I like to start by writing the charges. So Na has a positive 1 charge. PO4 is on your polyatomic ion sheet. It has a negative 3 charge. Now, Cr, chromium, is a transition metal, so we have to look at what it's bonded to. Cl is negative 1, but there's 3 of them, so that's really negative 3. So what cancels out a negative 3? A positive 3. So once I know all my charges, I know in double displacement, we swap the positives. All right, so Na is now going to bond with Cl. But we've got to be careful about these subscripts. Na only has a 3 right here to balance charges with phosphate. It's not going to be with phosphate anymore, so I'm not going to bring the 3 over. So I'm just going to bring over Na positive. I put the Na first, by the way, because it is the positive. Cl only has this 3 because we had to cross charges with chromium. That's how it balanced the charges. It's not with chromium anymore, so I'm just going to bring over 1, Cl minus. Positive and negative cancel, so we're good to go there. So now I'm going to bond Cr with PO4. I'm going to do Cr first because it's positive 3. PO4 is negative 3. So I don't need to cross anything. It already cancels. All right, and then last step is, or next step, it's not the last one. You wish it was the last one. I wish it was the last one at this point. Next step is to balance the reaction. So I have 3 NAs. Here I only have 1, so I'll put a 3. I have a phosphate, a chromium, 3 chlorides, and 3 chlorides. So now the last step is to use our solubility rules to determine, are the products aqueous, is there a solid, are we getting a precipitate or not, what's happening? So Na is on your solubility rules chart. It's a group 1 alkali metal, and it tells you it is soluble, which means that it's going to be aqueous. It's not going to be a precipitate. Cr is not on there. However, phosphate is, and it tells you it is insoluble. So it is going to be a solid. So if I mix these 2 chemicals together, I will get a precipitate, and it's going to be this right here. All right, so pause it, try this last one, and hopefully you get it right. I'll assume you've already gotten it perfectly right. All right, so again, I can see it's double displacement because there are 2 compounds that are paired up. So I'm going to start by writing my charges. So aluminum is positive 3. Sulfate is on your polyatomic ion sheet, is negative 2. Ammonium, NH4, is on your polyatomic ion sheet, is positive 1. And hydroxide, OH, is negative 1. So because it's double displacement, I am going to swap my 2 positives. So now aluminum is going to bond with hydroxide, which is OH. I'm going to put aluminum first because it's the positive one, but let's discuss the subscript first. Aluminum only has this 2 to balance with SO4 because it's negative 2. See, that's another thing that helps is if you write the charges, you can see what has been balanced. And so maybe that'll help you remember, don't pull it over. Okay, so this 2 was from balancing the charge with SO4. So I'm not going to bring it over. So I just bring over Al, positive 3. It's going to bond with hydroxide, which is OH negative. I need to cross the 3 down, but don't forget on hydroxide, even though it doesn't already have a subscript, it's still a polyatomic ion. So I have to put it in parentheses. All right, now NH4 is going to bond with SO4. I'm going to write NH4 first because it's the positive one. So NH4 positive, SO4 only has the 3 because we balance charges with aluminum. It's not with aluminum anymore, so I'm not going to bring the 3, but I am going to keep the 4, just like I did on ammonium, because sulfate is SO4, just like ammonium is NH4. One ammonium is NH4. One sulfate is SO4. All right, so I bring over SO4, -2, but I have to balance my charges, so I need to cross my 2 down. So I put my 2 like that. All right, next step is let's balance this equation. So we have 2 aluminum. Here I only have 1, so I'm going to put 2. I have 3 sulfates. Here I just have the 1 sulfate, so I'm going to put a 3. I have 1 ammonium, not 4, just 1. 1 ammonium, but here I have 3 times 2, which is 6. So I need 6 ammonium. And then here I have 6 hydroxide, which is OH. And I have 2 times 3, which is 6 hydroxide. Ooh, my plus sign is kind of getting lost in here. All right, last step is if I ask you about precipitates, you just have to put the aqueous in solid. Like, you got to use your solubility rules. So if you look, aluminum's not on there, but hydroxide is, and it will tell you it is insoluble, which makes it a solid. If you look, NH4 is on there, and it tells you it's soluble, which makes this aqueous. So if I mix these 2 substances together, I will form a precipitate, and it's going to be aluminum hydroxide. It will be my solid. Okay, so remember, it's okay. There's just my answer, if you can read those better. It's okay to get no precipitate. Sometimes when you mix things together, you don't get a precipitate. But it's not okay to get 2. Like, you're not going to get 2 solids. All right, so hopefully this section wasn't too terrible, but you know, you really just got to get good at charges. The better you are at charges, bonding things, crossing charges, understanding polyatomic ions, the easier all of this becomes.